So we're going to now do the second half of, what is this, 7-5 we're on? 1-7, excuse me. The second half of 1-7. And the second half is dealing with the distance formula. Now, here's the thing with the distance formula. There's a dorky math formula way to do this that is going to make you hate negatives the way you just hated negatives before. So we're not going to do that. I'm going to teach you where the distance formula came from. It's probably good for you guys to understand what the distance formula is. And maybe some of you who are like really dorky and love numbers, maybe you could use the formula. If that's you, go for it. But I don't want to deal with all of the negative chaos that's going to happen with everyone. So let's write out the distance formula. The distance formula is this. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. We're not going to use that. The procedure, and it's good for you guys to be aware of this because other teachers will tell you to use that. Let me tell you where this comes from. And this distance formula is supposed to be a shortcut. It's supposed to be a shortcut that makes things easier. I'm going to tell you right now, doing it the long way is actually easier than that shortcut distance formula. So here's the procedure that we're going to do. You are just going to graph and use Pythagorean theorem. You guys should have some exposure to Pythagorean theorem. If you don't remember it, it'll come back to you as I go over it with you now. In fact, you're not always going to graph and use Pythagorean theorem. You're only going to do it in some instances. So in this section, they're not asking to find the midpoint. They're asking, how long is the line? All right? So they're going to ask, how long is the line? The first section that we're going to talk about is we're going to talk about ones that are really easy to do. And we're going to talk about why they're so easy. So the first half, these are easy problems. And an example of an easy problem would look like this. They would say, what's the distance between a point that's on, I'll even make it negative, and I'll show you that it's easy even with negatives, the way that we're going to do this. We'll say 2, -3. And we'll go with 2, 4. The way we're going to do this is that you are going to make a coordinate plane graph. You're going to make a graph, and you're going to graph these two dots. They're going to give them letters. You're even going to put the letters. We'll use A and B. They might use different letters, whatever. You're going to put the letters they have on there. So we'll go to the right 2 and down 3. 1, 2, 3, put a dot, label it A. Now to the right 2 and up 4. 1, 2, 3, 4. Put a dot, label it B. What the question is asking is, what is the distance of a line that goes from A to B? You do not need to use this formula to figure that out. Just count the lines. Let's count. How long is this line? 1, 2, 3, 4, 5, 6, 7. The distance here is 7. All you got to do is count. Easy enough, isn't it? Like literally just count. So who cares about doing all of this annoying algebra where you have like a negative and a negative, and if, right? It always gets people. Do I add these negatives or do I subtract them? And it's like, well, sometimes you add them and sometimes you subtract them. You can see, right? Some people's like their brains pop when they try to figure that stuff out. This way you don't have to do it. You just count. Easy enough, right? Here, let's try another one. Let's see if you guys can do this one on your own. You guys graph this out, count it, and then we'll keep going. All right, here we go. Example 2. Let's do this one. We're going to go with -3, 1 and -5, 1. Graph those two dots out, -3, 1, -5, 1. Count the distance. Oh no, what happened? There we go. I'll put it over here. -3, 1, -5, 1. Oh, I forgot to label them. We'll label them R and X. So the first one's R, the second one's X. And then you're going to make a line. What's the distance of the line, guys? Can we just say, come on now. There's no way you struggle with this. Let's try to shout out the answers here. What's the distance of the line, guys? Okay. We got to be clear here. Do we all get that this is 2? I was expecting like everyone to yell 2. So now it's like, we all good with 2? Yes? Bren, you get 2? Okay. Let's just like all shout out answers when you get it. Instead of making this mystery, you have to run around. Okay, go grab it out. All right. That's way easier than doing some crazy formula, isn't it? Here, let's try another one. We're going to try to do example 3. We're going to graph 1, 1. And we'll call this point W. And we'll go with 5 and 4. Graph those two out. Tell me the distance. No more being shy this time. Graph it out. I'll say, hey, what's the distance? You guys just shout out the distance right away. It's not that hard. You just make a line, count how long it is, come up with an answer. Graph them out. Make 2 dots. One, put it. Oh, I forgot to label the other one. We'll call it W, and we'll call with G. 1, W. To the right, 5, 1, 2, 3, 4, 5, up 4, 1, 2, 3, 4. Call this one G. Make a line. All right, what's the distance? 4? It's not 4. It's not 5. It might be 5. Where'd you get 5 from? No, you didn't. Bella, what's the distance? Do you know the distance? You guess the distance? Can you count the distance, Bella? Bella's really smart, by the way. Can you count the distance, Bella? Why not? What? You can't count? You're telling me you can't count? Why can't you count? This is important. Why not? Yeah. So look, you guys need to see the difference here. If it's a straight line, this I can just count. 1, 2, 3, 4, 5, 6, 7. This I can just count. 1, 2. What's different with this other line? What's the difference with this line? Why can't I just sit there and count this? It's diagonal, thank you. You can't count these diagonal lines because this is going like some crazy weird fractions. So once it's a diagonal line, now we need a different procedure than to just sit there and count it. The procedure that we're going to do instead of just sitting there and counting it is that we are going to use Pythagorean theorem, and we're going to make a little right triangle. So now we're going to make like little dotted lines that are pretend, and we're going to make a little right triangle. Now, the reason why we have a right triangle is because now we can count these two sides. Look at this side here is 3. 1, 2, 3. Oops. Do you see how I can count that that line is 3? That was easy to count because it's straight. It's not diagonal. I can count this one as 4. 1, is it 4? Did I do something wrong? 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, wait, did I do this backwards? 1, 2, 3. Oh, there we go. I just counted wrong somehow. 4. So I got one side is 3 and one side is 4. I can just use Pythagorean theorem. Look, this is like the hypotenuse of it. Pythagorean theorem is just one side squared plus the other side squared equals the hypotenuse squared. Now I can figure this out. 3 times 3 is 9. 4 times 4 is 16. 9 plus 16 is 25. You guys all should have some exposure to Pythagorean theorem. Then you take the square roots. The square root of 25 is 5. See, all you're going to do is use Pythagorean theorem to figure out what this diagonal line is. We have to use Pythagorean theorem because you can't just sit there and count it. Yes? It is, yes. And so for those of you who are aware, I'm not going to teach Pythagorean triples to everyone. That would be enough work. You could just say, oh, I know it's a Pythagorean triple. Let's try to do, actually, instead of doing another example, we're going to do one from your homework. Or one from the word, just to give us some more time. So that's the second part of this lesson where we're going to do the distance formula.